Exercise 16.3, question number 1. Which of the following cannot be valid assignment for probabilities for outcomes of sample space S, which is given by omega 1, 2, 3, 4, 5, 6, 7. Assignment is given. Omega 1, omega 2, omega 3, all the values have been given. Now, I have to check whether the sum of all the probabilities is going to be 1 or not. If all the probabilities add up to 1, then I can tell that it is going to be valid assignment. If not, it is not going to be valid. As simple as that. So first, let me add up all the numbers, probabilities. So 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.1 plus zero point 0.6. When I add all of them, what will I be getting? Will I be getting 1? Yes, I will be getting the answer as 1. Since I will be getting the answer as 1, I can write the given assignment is valid. The given assignment is valid. Next, 1 over 7, 1 over 7, 1 over 7 and 1 over 7. Again, when I add all of them, 1 over 7, 7 times when I add, I will be getting the answer as 7 over 7, which is going to be equal to 1. Since the sum of all the probabilities of the sample space is equal to 1, even this assignment is going to be valid. The third one, 0. 0.1, 0. 0.2, 0. 0.3, 0. 0.4, 0. 0.5, 0. 0.6 and 0. 0.7. When I add all of them, will I be getting 1? I have to check. 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0.6 plus 0.7. 7, 7, 18, 18, 2, 20, 28, 2.8. The answer is going to be 2.8. It is not going to be equal to 1. Since 2.8 is greater than 1, this is not valid. This assignment is not going to be valid. The next one is going to be D. 0.1, 0.2, 0.3, 0.5, minus 0.2, minus 0.1 and 0.3. Can this be a valid assignment? No. The answer is no, because probability cannot be a negative value. The probability cannot be a negative value. Similarly, you can solve the other problems as well. Let us go to the second problem. A coin is tossed twice. What is the probability that at least one tail occurs? Let me start by writing down the sample space. Sample space for coin is given by 2 to the power n, where n is the number of times the coin is tossed, or how many number of coins are tossed simultaneously. For both, the sample space is going to be the same. Here it is twice, 2 raised to the power 2, it is going to be 4. I can write the sample space S, which will be equal to head, head, tail, 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 head, and head, tail. I have to find the probability of the event E. Let me consider the event as E. Let E be an event such that we get at least one tail. There has to be at least one tail, meaning that one or more than one. So here we have two tails. So this can be taken. Here we have one, this can be taken. Here also we have one tail. So here this can be taken, except head, head, all the three can be taken. Now, the probability of event E is going to be number of favorable events, which is going to be 3, divided by total number of events, which is 4. So the probability is going to be 3 over 4. Question number 3. A die is thrown. Find the probability of following events. The first one is prime number appears on the die. Okay. So the sample space is taken as 1, 2, 3, 4, 5, and 6 for a die thrown. Now, we can assume the first event to be A. Let A be an event of getting a prime number. What are the prime numbers from the sample space S? It is going to be 2, 3, and 5. 2, 3 and 5. So 3 prime numbers are there. Probability of getting a prime number A, event A, it is going to be getting a prime number, it is going to be 3 divided by 6. The answer is 1 over 2. Second sub question. A number greater than or equal to 3 will appear. Let me consider A to be the event of getting a number which is greater than or equal to 3. What are the numbers which are greater than or equal to 3? They are 3, 4, 5 and 6, right? 3, 4, 5 and 6. Now the probability of event A is going to be number of favorable events, which is 4 divided by 6. I can write this as 2 divided by 3. This is going to be my answer. Third sub question. A number less than or equal to 1 will appear. Let me consider A to be the event of getting a number less than or equal to 1. Less than or equal to 1. What are the numbers which are less than or equal to 1? It is going to be just 1, right? There are no numbers which are less than 1. So only 1 is going to be the event over here or the element over here. The probability of event A is going to be 1 over 6. The next one, a number more than 6 will appear. A number more than 6 will appear. Let me consider A to be the event of getting a number which is more than 6. Number more than 6. Is there any possibility to get a number which is more than 6? No, right? So the probability of event A is going to be 0 over 6. The answer is 0. The fifth one, a number less than 6 will appear. Let A be the event of getting a number less than 6. Which are the numbers which are less than 6? 5, 4, 3, 2, 1. There are totally 5 numbers which are less than 6. Probability of event A is going to be 5 over 6. 5 over 6. Question number 4. A card is selected from a pack of 52 cards A. How many points are there in the sample space? So here I have written down a table. In a pack of cards, there are totally 52 cards, and 52 cards are divided into 4 groups of 13 each, where 2 groups are going to be in red color, 2 groups are going to be in black color, right? Do you know the names of these? This is spade, this is diamond, these are hearts, these are clubs. These are clubs. The first one is, how many points are there in the sample space? How many points are there in the sample space? Totally there are 52 possibilities. So I can write that number of points in the sample space is going to be 52. This is going to be your first answer. Next, B. Calculate the probability that card is an ace of spade. Ace of spade. So how many ace of spade are there? There is only one ace of spade, right? So let A be the event of getting a card which is an ace of spade. Only one ace of spade is there. Probability of A is going to be 1 over 50. This is going to be your answer. See, calculate the probability that card is 1. An ace, second a black card. Second a black card. Okay. First, let me consider an ace. How many aces are there? First one, let me consider A to be an event of getting an ace. So we have 1, 2, 3 and 4. We have 4 aces. Probability of getting an ace is going to be 4 over 52. 4 over 52. Further, you can simplify this as 1 over 13 also. The second one, black card. Let B be the event of getting a black card. How many black cards are there? 13 over here, 13 over here. So I can add both of them. 13 plus 13, it is going to be 26. Probability of getting a black card is going to be 26 divided by 52. The final answer is going to be 1 over 2. Question number 5. A fair coin with 1 marked on face and 6 on the other, and a fair die are both tossed. Find the probability that sum of numbers that turn up is 3 and 12. 3 and let us assume that 1, 2, 3, 4, 5, 6 are the possible outcomes when the die is thrown. A fair coin with 1 marked on its face and 6 on the other. Okay. And a fair die. There is a die and there is a coin which are tossed. Let me start by writing the die. For the dice, the sample space of the dice is going to be 1, 2, 3, 4, 5, 6. Right? Next, we can write the sample space of the coin. The sample space of the coin is usually head or a tail, but here it is marked as 1 and the other face is marked as 6. So the sample space of this special coin is going to be either 1 or 6. Either 1 or 6. Now, the sample space is going to be total sample space. This will be equal to, so a fair coin is tossed, then a die is also rolled, right? Now, I can get 1 here, I can get 1 over here. I can get 1 over here, I can get 2 over here, I can get 1, I can get 3, I can get 1, I can get 4, I can get 1, I can get 5, I can get 1, I can get 6. So on a coin, I can get 1 first, then all these numbers I can get. Or I can get 6 on the coin, then all the numbers I can get. 6, 4, 6, 5, 6, 6. Totally, there are 12 elements. The sample space is going to be equal to 12. The sample space is going to be equal to 12. So the first one, for the first one, I can write n of the probability, say, yes, let me consider over here. Total probability, total sample space is going to be equal to 12 over. This is 12. Now, find the probability that sum of numbers turn up to 3, right? We have to find out. 1 second.